Hello, Assalamualaikum. Very good morning to everyone.
Good morning, sir.
Sir.
How are you? How is everyone today?
Doing good.
Doing good, yeah. All right. So basically, we are, basically in the final week, right? Week 14, and most of your tasks, assignment, coursework, tests, right, have been completed. I hope so. At least on GIS part and census parts, everything has have been completed by you. How was it so far doing online classes? Not only this one, but other subjects as well. How do you feel?
So stressed.
Stress, huh?
Yeah.
Is it troublesome in terms of what we call that technical? I mean, line, internet, and all.
Line lah, especially.
Especially line, yeah.
Yeah.
I thought KJ, right, has sort of conducted the trial, right, for your examination yesterday. Was it yesterday or the day before that? I don't know.
Yesterday.
Oh yeah, yesterday, right? But she told us, the department, that you were right running a lot of issues and doing online for at least 1 or 2 hours when you're doing your tests or examinations. So I think the department had not to go with opening your webcam. I mean, we have to let it go actually, because there's no way that we can sort of monitor each and every one of you basically doing your answers and whatnot, right? It's just a matter of this university requires us to make a proper, I would say, monitoring basically. Then that is one way that we can think of. Basically, there's no other way, right? It's, to be fair, I mean, camera on is the only way to go. But I believe some of the faculties like dentistry, I think medicine, they really stress on, or they put the strict requirement for the camera to be on during the session, during your examinations. But I think for us, for Alam Bina, at least we would not do that. Okay, regarding that, yes, the questions, the examination questions, they are all set. And it so happened that I will be in charge of that during the examination day. This guidelines is quite similar with the previous semesters. I think you all have what we call experience that, right? Doing online examinations where we require you to write in the answers and then later using, let's say, cam scanner, and then scan and then send as PDF, right, to Spectrum or to Google Drive and so on and so forth. I think you all have understood that process, right? Do you agree with me?
Yes, sir.
Okay. So basically this semester is going to be the similar. So basically in relation to that, because the department, I think not only the department, but the faculty, the university also has sort of, not to say instructed, but made mandatory for all lecturers to prepare some sort of prepare the final exam questions that are not that cannot be directly get answers from the question when you read the questions, and then you simply can get the answers from like anywhere, for example, right? Well, of course the answer somewhere in the notes, right? But it should not be direct answers. That's what we were told. So in order for us to prepare the questions, we have thought of these things. Maybe not 100%, right? Because we need to give some leeway also to the introductory part of the question as well. So you will find out later on that your questions would be much, more or less similar to the normal circumstance when we do the sit-in examination during non-COVID time, right? But please do note also that there will be some questions, not only GIS, but other questions in other subjects. that could be, you need to understand, right, the questions, and then you need to provide the answers. That could not come directly from, I mean, through by, sort of copying the notes, right? Just bear in mind of that. And then as far as GIS is concerned, and statistics also, if you do the what we call that, the tutorial activities and possibly some tests, right? They are somewhat reflected upon the examination as well. So basically, if you have participated in the tutorial, as well as class activities, or any tasks that were given to you on Spectrum, that would greatly help you in terms of doing your final examinations and the answers. All right. And probably some of the tasks, okay, over your tutorial might be repeated, okay, in your questions in final exams, right? Just that's good. That's actually the sort of the best tip I can give you. Just take note of that. All right. So if you do the task, and then you should not be having problem when doing the exam, right? And the format for the examination is like this. We have 4 questions altogether, but you need to answer 2 only, right? So we have section A, statistics, 2 questions, answer 1 question, and then section B, GIS, 2 questions, answer 1 question. So altogether you have 1 each, right? So total 2 questions. And the time given is 2 hours to write in your answers, and then plus 30 minutes for you to do the submission. All right, 2 submissions, to Spectrum and to Google Drive, right? And then I'm sure you know the drill, right? You know the drill because you have done it before. You need to submit within that 30 minutes, extra time. Otherwise, the marks or the paper would not be accepted, right? By the university. I mean, by the lecturers. Okay, so in all you have 2 plus 30, 2 hours plus 30 minutes, and then that remaining 30 minutes for you to submit the answers. All right. So have you know the date of your examination? Was it on the 4th?
Yes, sir.
4th, yeah, 4th February, right?
Yes.
Okay, 4th February. So basically, before the expected time of your examination, was it 11 o'clock or afternoon?
2 p.m. At 2.
2, right? 2
Yeah.
p.m. Eh?
Yeah.
Okay, so you will start at 2 p.m. on the 4th of February, but slightly before 2 p.m., like 10 or 15 minutes before that, I will simply upload the questions on Spectrum. I will make it. I will open the questions like 10 or 15 minutes before the time starts, all right, before 2 o'clock, so that you have time to read and just sort of formulate sort of the answers and plan for answers. So, or at least 10 minutes will be given to you to read the questions before the actual time starts at 2 o'clock, right? So I hope you understand on that, yeah? Okay, I hope to see you on the 4th, all right? Final date of your examinations. And then today, we sort of going to review some of the work that we have done. And I also would like to introduce to you with one sort of final or last topic for something related to GIS as well, which is actually land survey, right? But before that, I would like to share with you some of the answers that you have submitted, right? Let me share you my screen. And before that, I'm going to record the meeting. What's the benefits those who can't make it today? All right, present now, entire screen. Okay, I picked up some of the work that you have done. This is actually the group work, right? Your tutorial 10 on the GIS database. Where was the question? Yeah, oh, right here. Oh, here. The question is here. Okay, so basically the question asks you to prepare the database conceptually, yeah, right? Conceptually, because we can't do it over the computer or on the software, so we sort of imagine how the GIS data would be look like before it being is being transformed into, sort of digital process, right? So the tutorial asks you to provide sort of conceptual design, and you need to prepare two things here. One is the ER model, and the other one is actually the relational model, okay, which is actually related to ER model, all right? It's quite a straightforward actually task for you to do, but the bulk of this task, right, is over here, application description. You just need a bit of imagination, all right? The application consists of operations of registered office, or it could be any operation of registered office, right? So it could be valuation firm, asset agent, property management company, or developer company, or any other kind, right, that operate as a real estate office as the main core, right, of the service. So basically, the office needs to keep track items. We call it entities in that database, right, which is the headings of each of the columns, right? Such as agent. These are all examples, all right? So from these examples, you need to prepare ER model to show the relationship. And then you need to construct the database model, all right? So I pick up sort of two submissions here. Two submission, but I mean by two group submissions here, I guess. Yeah, this is group by Shirley, Susan, and Nurul right? A very nice, picturesque, what we call model, and it's colored even. Okay, so this is actually how it looks like. It should be look like. Okay, this is correct, right? So what you need to do is sort of create some sort of entities and their attributes related to these entities. Okay, and then this is actually the process. All right, this thing is the process or how it relates to, let's say, this entity payment to a client. So client make payments, and then these are details, all right, of each of the entity, and then how basically client sort of relates to the other entity as well. So client relates to client contract, all right, and branch. Okay, for example, okay, in this case, all right, and then this process is actually repeated, okay, to basically, prepare or make or create a relationship with other sort of entities, all right, that you can think of. For example, you have the staff, probably by, HR department, linked to this employment contract, okay, for each employee. And then these are some of the, what we call details or the attributes, right, of the entities, all right? Okay, and you have location, and possibly location can be model based on spatial data. Okay, if you were to transform into a GIS database, right? And property also can be sort of modeled spatially, all right? And then now we also have what we call this relational diagram. Okay, it shows here the link between, let's say, client here to the payment terms, all right? But please note, the relationships, I mean type, one-to-one, one-to-many, and on all. It says here, clients and property. In this case, let me enlarge the size. Okay, client and property has a, what we call, what's it, one-to-many, yeah, in this case. How do you explain this, this group? Can you just simply go through? Anyone from this group?
Hi, sir.
Yeah,
I'm
hi.
Susan.
Yes, Susan. Yes.
For this, actually, I quite not remember about the arrow because the symbol, when we do, we refer one by one. So
okay.
Now I cannot really remember the arrow symbol.
All right, so just take note. All right, maybe you can refer it back later on. Just note that the relationship shown here would it something like related to one entities to many entities, or one to one only. Yeah. So basically, this arrow will depict that in terms of that relationship here. Okay, just take note, right? No problem at all. Okay, no problem, no issue. And then let's look at another group here. Just bear in mind, I pick at random only. Okay, I'm going to show with you two sort of submissions. So here we have whose group this one? Yeah, I couldn't remember now where I picked it up. Who remembers who done this? Anyone? Whose group is this?
I think teaching.
I can't remember.
When we did.
Oh yeah, when we did, is it?
Yeah.
Okay. Is your group also, Lavinia?
Yeah.
Okay. Probably you can take us through. Just briefly describe about your process here, about your project here. We sort of this office here. What sort of office here you talk about? Evaluation.
Evaluation firm.
Okay. So I see here. Yes, please go on.
Yeah, so we have like the department and then all the type of information that they would have to keep. Yeah, and then so then we have all these other entities like the clients, the bank, the valuers, and so the diamond thing is the relationship, like the staff is the valuers, and then kind of thing, yeah.
All right. Okay, good. All right, get information from government agencies. Okay, basically what we get from government agency is actually the data, the sales data basically.
Yeah.
Because only government agencies can have the sort of official data on sales transactions of any property. And then here you transform that into the relational model, yeah? Okay, that's good. All right, I hope everyone also has done a good job over here. Bear in mind, you need to think of on this question, on this work, okay? Might be come up again in your exam, all right? Okay. All right, great. Okay, and then I think everybody has submitted their test also. Okay, that's good. Most submitted through Spectrum, and then there are a few submitted through emails. Both also accepted. No worry about that. I will sort of go through all the work okay later on. Where was it? Here, right? Okay, Google Drive. I've seen a lot of submissions here. Right, all of this. Okay. All right, and some or only a few, like 4 or 5, submitted over the email, using the emails, which is no problem at all. All right, so I will go through this one if I want, and then provide you with the marks later on. Right, but don't worry. I think as long as you have done the task, I mean, following the questions, and then you shouldn't be have any problems getting marks for that, getting good marks for that and for that work. Just bear in mind also, this type of questions or this type of activity could be repeated, right, on your exams. I say could be, okay. Don't put high hope on that, all right. But let's hope so, okay. As long as when you come back, you simply practice again, then you should have no problem, all right, to do this work, okay. So here we simply ask you this one quite a light sort of exercise for tests. All right. What I'm promoting here is actually for you to understand the sort of the basic principles of GIS, through contextual way. Okay, because we cannot simply go on with the software, the proper GIS software, because it's quite troublesome, right? And then there's no sort of the software that I'm used to. Okay, I could not get it for free. Okay, so it's quite impossible for us to do or to run through the exercise over the software, because I am quite familiar with two software, MapInfo and ArcGIS. All right, and then these two basically have what we have that in our computer labs, and then I have sort of regularly use MapInfo for the exercise, because it provides with easy, explainable sort of way to do or to perform the task, right? on map info. Okay, it's more user friendly compared to ArcGIS, right? So here we simply ask you to prepare a spatial attribute database using Google Maps. Okay, this is the one that we can get it for free. All right, it could be free for life, something like that. Okay, as far as we know, okay, at the moment. And then you need to select any area within the Klang Valley from Google Maps, and then you need to name the themes for the maps, right? These are only examples, okay? And then build a real estate spatial database that includes two spatial entities, points and polygons. Okay, these are all vector data, right? And then create 2 spatial layers, and each layer should contain at least 10 spatial entities, right? So layer 1 should be points, and layer 2 should be polygons. So there you have 2 layers. And then each layer, points need to have 10 items, and then polygons also needs to have 10 items, which is supposed to be 10 polygons, right? And then we need to have 10 points, okay? But must be arranged on 2 layers, yeah, 2 spatial layers. So one entity must be area, okay, the size, okay? And then of the polygon you created, okay? Of course, you can get size only on the polygon, right? You cannot get size from points because it doesn't have any relationship with other segment, okay? Because point only has a single dot. But polygons, you have the start point and then closing back to the same point, right? And then it's supposed to be enclosed. So that's why we have the size, okay, of the polygons that you created. And then you could add any descriptions, or you could link with the image or video related to some feature object. And then I also require you to create at least 5 attributes, right, related to real estate data for each of the spatial object, all right? So for example, 5 attribute, basically 5 data, okay, 5 subset of data, all right? So if you have, let's say, points, okay, let's say you start off with POI, a point of interest, and then you have the location, the size, that is the entities, and then under each entity, you need to have created at least 5 data, okay, over each sort of entity. Okay, so basically, if you have done that, then you should have no problem to get good marks on the test, okay, on the exercise. Just bear in mind that this test counted for 30 marks of your overall assessment. Okay, share your work by enabling the link sharing. Okay, this one should be no problem, right? Okay, and everyone has submitted that. That's good, right? Okay, let's move on to sort of today's presentation. Today's lecture. Basically, we are going to do or to see some things about land survey. Okay, remember on the first sort of lecture on GIS, I have explained to you about the sort of historical context, all right, of the GIS data, okay, especially special data, all right, and then of course we start off everything from the survey of land features. Okay, and then surveys transform onto maps, cartography, and then maps transform onto digital form that creates a GIS database, all right? So GIS basically utilizes land survey, okay, or the work of land survey to provide GIS users with the raw data, right? Especially on spatial data, which are the maps, right? So that's why we need to know a little bit of land survey. But during the earlier times of this course, all right, like 10 years ago, we do have this land survey subject, all right, where students needs to do a bit of theory as well as practical on site. Okay, and they did actually measure, okay, like the one you saw here, that like what you see here, okay, on this picture, in this picture. Okay, the user needs to bring the tools, the theodolite, for example, to plot what we call the data, and then to draw or create what we call this polygon, right? And of course the data relates to the the bearings, all right, as well as the distance, let's say from this point, and then you need to measure or survey all these sort of corners, okay, of this platform or of this feature to create what we call some sort of a boundary. for a land, let's say a land parcel, for example, right? And then through this subject, you basically could define what is land survey and other terms related to land survey. And then you could also describe the importance of land survey, especially what land survey can do with sort of real estate, right? Or how can real estate benefit from the use of land survey. Of course, you don't do land survey when you do your real estate task, right? You don't actually go to site, right, to get the data, but you have somewhat used the data from what the land surveyors have collected, right? Especially in your plan, right? Site plan, especially, from that document title where you see the site plan, and then that plan has already been that land, for example, has already been surveyed, okay, by the land surveyor. Okay, and then you can know what you call the application of land survey in real estate. So basically what survey do is actually collecting data, okay, that is what they do actually, all right, and then they sort of define the exact position on Earth with whatever tools that they have at hand, all right, when they are collecting what we call point data, and then the other multiple points data as well. And then basically what's important here, this data, okay, this raw data forms what's called the basic input for the GIS operations that we use, right? Or that the user employs when they carry out their activities or their purpose. Okay, a bit of introduction. Actually, surveying is one of the surveyor's disciplines, right? If you look at RISM or RICS websites, okay, or portals, you basically can note of the importance of one sort of professional's field, which is actually land survey, besides property, quantity, building, right? So we also have what we call land surveyor. And then what they do is actually they measure and collect, okay, all the important data about Earth, right? They can do it, they do not only measure or pick up what you call data over the surface, but sometimes, on the surface, but sometimes over the surface as well as below the surface, okay, at sea. We call it hydrographic survey, right? And then, of course, there are various sort of modes or methods as well as tools and equipments they use, okay, to get what we call the data. Right here is actually the RSM website. Okay, you see here surveying divisions. All right, we have 4 basically, right? One is actually land survey here, and land survey now has been renamed to geomatics and land survey division. Geomatics to simply relate to the what we call the GIS or the computing part, all right, of the survey. Okay, like my master's degree in geoinformatics, all right, that is actually something related to GIS, okay, directly. So you can have land survey, geomatics, or geoinformatics, all right. And then we also have the other divisions that we have here, okay, in the faculty, quantity surveying, property surveying, which is you, all right, and then we have also building surveying. So basically, all these main professions are regulated by RSM, and then all has their own what we call board, okay, board of governance. Like for us, we have board of valuers, and probably land survey has their own board of land survey, right? And these are other names, geomatics or geoinformatics, because it expand beyond the traditional surveying that have what we call this digital or computerized sort of data, all right? Okay, a land surveyor, these are some of the tasks, survey plots, okay, of course, this is actually the main task, okay, the main role of a land surveyor. And then they also determine the property boundary through surveying, okay? Remember that your title, right? Sometimes we have this qualified title, sometimes you have the temporary title, okay? Qualified title means probably the land has been surveyed, okay, properly, all right? And then the temporary title has also been surveyed, but needs to be finalized, okay? Because they need to survey first and then to do these proper subdivisions, okay, before they handing over the individual parcel to the landowner or to the property buyers. And then later on, through the process, probably they will come again and then they will do the proper surveyed, all right? So that it's going to be, I mean, the area of that parcel is going to be like final, right? So that's why in your title you have luas sementara, and then you can only have luas sementara or luas, all right? So luas means it's already final. Luas sementara is going to be surveyed again, all right? So basically, all of the information is important for, especially development, okay, in real estate. Of course, it simply helps the, probably the developers to put a layout, right? Or to transform what they have planned onto the actual site, all right? And then it also helps determine all the features that they have made on the plan, and then transferred it on the actual site, right? And then sometimes these property boundaries, all right, also settles property line disputes, or sometimes, an owner of the adjacent lot, right, wants to get access, okay, through easement, or to the greater extent to the the government is of right of way, right? They call it hak lalu lalang pentadbir tanah, right? That is actually government side, and then we have easement is actually the private way. Okay, so basically an owner could have, both. They need to apply for easement first. If that doesn't work, and then they need to go to the option one, which is actually the government channel. And then this information about land, about any features, okay, on earth, would be very important for the cartographers to prepare maps. And then these maps would be digitalized to become what we call the spatial or GIS maps, all right? Just a general definitions. Remember, similar to us, the arts and science, okay? But for surveying, is actually arts and science of what we call the measurements, okay? Sometimes we cannot get the actual measurement, because when surveyors do measurements, they need to refer to what we call the meridian, okay? Because they need to get the actual sort of measurement, okay, on the site, right? So that's why sometimes when you have the bearings, okay, bearings sometimes deviated, okay, by what we call this, by the globe, okay, by this meridian, okay. That's why we have sometimes the true north is not really a true north, like 0 degree, but it could be sort of deviated slightly, okay, maybe 1 or 2 degrees, right, deviation, okay. That's why we call it what we call a meridian north, right? It's not a true north, right? And then survey is a way of getting the relative position of the points, and then when the point is plotted on the paper, so we can show it, right, on the map. And then when we have data on the map, and then it becomes digital, so it becomes GIS materials, so we can do much more, okay, like what you have done a little bit, right, on your exercise over the Google Maps, right? So we can get to know, features, especially on Earth or on the surface, and then we can also plan, right, our journey, for example, and then we can, sort of create a relationship from one point to, or we can establish the link, okay, between one point to another, for example, right? Oh, sorry. I lost this screen. Okay, here. Okay, this is how a surveying look like. So you have a parcel or plot of land, for example, that needs to be surveyed, like here, for example, and then this surveyed data actually transformed into map by the map makers, or then, right? I mean, then historically, in probably 1970s or 80s, we have these cartographers, okay, who sort of, simply plot what we call data of measurement from the land surveyor onto sort of like AO sheets of paper, right? And then this is what you have nowadays, probably at work, right? When you do valuation later on, you will come across this what we call RSS sheet. Okay, have you ever heard about RSS sheet in your valuation subjects? Anyone?
Tak pernah, sir.
RSS, I'm sure you have, somebody has mentioned to you, right? It's related to the land map, okay, to the parcel map. You look it up, RSS sheet, okay, something like revenue survey sheet, something like that, okay, that's what you call. And then here, this traditionally they draw, okay, on the piece of paper, and then since the 90s, for example, they simply turn this map into what we call digital maps, from paper-based to digital maps. So that's what we GIS can sort of do more operations, okay, when we have digital data, okay, over the map. All right. In fact, the storage of this data only needs more megabyte, for example, compared to let's say stack of papers. All right, a big chunk of papers, and then you need a big room, for example, to store all these what we call maps. Right. So I imagine it's important. This is a bit what we call it philosophical, basically. So we define our system by how we relate to what is around us. Okay, this is related to the Tauber's law of geography, basically. So basically, when we do measurement, we want to know what's actually happened, okay, near us. Okay, of course, we cannot see what is actually happened over the distance, right? So the near things are much more related to us, okay, compared to the distant thing. So that's why we need to know what is happening around us. All right. So basically, by measuring, we are able to better quantify and qualify our interaction with the surrounding world. So this one a bit of philosophical aspect, right? So basically, surveying allows us to get accurate and valid measurements, right? Purpose of surveying. Okay, these are what surveying do. What surveying does to raise it. All right. Of course, one is actually to determine the relative position, so that as the relative person, you can, if you were to, let's say, inspect your property, your subject property, and some of the comparables. All right. So you need to be there at site, on site. So this basically map, okay, or survey map, okay, can be very beneficial to you, okay, to get to your location, right? So basically, it determines the relative positions. Okay, sometimes it's not an actual position, but relative position, okay, to lay out mark positions, okay, by way of this map, okay, right, to mark, okay, all these sort of boundaries, all these corners, okay, and then determine areas and volume, okay, that's why you get the area for your land, for example, and then to prepare a map and detailed plans and a topographical map that relates to the contours, okay, of the features, okay, on the earth, right? So basically, it's all begin with what we call a position. Okay, so and then you can get all other references or all other sort of items. Okay, this only from a proper location or proper position of a single dot, right? And then when you connect all the dots, so you get what we call the areas, and then you can get what we call the parcel. This one is a bit something a technical tool than survey, basically. So survey can be classified into two. One is by objective, and then the other one is by the tools that they use. One, we have the plane survey. In Bahasa they call it Ukosata. Okay, plane survey is basically when the Earth surface is horizontal. All right, it's like the Earth, you simply cut through and then you lay it out, okay, as a flat platform, for example. And then you have the other one is geodetic, that simply focus on the curvature, all right, of the Earth. We need to say that you are actually looking on items like what's the contours, okay, of the surface, all right. And then through measuring tools, okay, these are some of the example of surveying tools. The Gunter's chain, this is actually very classic. During like I think the 80s and 90s, right? The valuers, when you do let's say when you want to measure the distance of your agricultural land, which sits, let's say, on the second or third layer, which is actually further inside, okay, from the main road. Sometimes because they need to identify the what we call that, the milestone, the bound miles, the the boundary stones, for example, of that land, because this is actually agriculture, right? So you cannot have a proper land like you go to a house, cemetery or terrace. So you have a good sort of size of a rectangle, and then you can identify it from the roads. But let's say for a second, third layers, okay, of agriculture land or any other land, right? So you need to simply identify the boundary stone, and then you need to measure, okay, from the main road, how you get access to that land, all right? And then those times they use this Ganter's chain, or this space chain, they call it. So just imagine you need to carry this chain when you do what we call agricultural or forest-based what we call valuations, right? So that you can explain or describe how you get to the site, okay, or to the site of property from the main access road, all right? Just imagine a second, third, fourth layer, okay, from the main road. And then you cannot justify the boundaries of the land because, I mean, you can refer from your site plan, for example, but you need to really identify the boundary stones. So you will get to know the information or the data about the site, okay? Because in your report, right, you need to write the description on the site, okay? And then this simply would be very helpful. But of course, through evolution, surveys nowadays have this EDM, okay, electronic distance measurement. Okay, this is actually more digital, right, compared to simply running the tapes, right? In fact, in early 2000 also we still use tapes, right? This type of tapes. And then probably nowadays, okay, some companies have ventured or have invested into getting this electronic digital measurement or EDM. And then these are some other items. Prismatic compass, you want to get the bearing, okay? All the sudut. And then GPS, you can get the point location where you are, and then it also can show you the trail, right, of that points, all right, from the start to the destination, for example. And then these are some other tools, a rod, where you place the rod as a target, right? When you get a bearing from the compass, and then this is actually what you aim, okay, the rod. So it actually becomes a target. And then this is actually another thing when you do leveling, all right? When you do the cut and fill valuation. Did you do cut and fill valuation? Somebody taught you that? We call it cut and fill, And then probably these are actually the items that you need to use, level stuff, because level stuff can measure what we call the churron, okay, up and down, okay, of the surface, right? And then these are some of the sort of measurements on the target, target, simply like rod, but for level you need to see the target here, and then the readings are all on the target, because you do not want to get only the bearing but also the level. Okay, remember level is actually the elevation or the height, okay, of the surface, because it is actually up and down, right? That's what a level stuff do. And then that is actually very helpful when you do what we call cut and fill evaluation. And these are some of the more sort of modern tools. In fact, nowadays we don't use prismatic compass for bearing, but now we have these more advanced tools like total light or total station and level tool used to get what we call the elevation or the height sort of figures, okay, of the land. Classes of survey, just focus on the layout survey, okay, here that related to real estate, right? So marking on the ground features like here, and then you could also have what we call property lines for subdivision work, right, to show as the layout survey. Like here, you have all parcel based, and then this is what the men do to actually create all these boundaries, right? Types of survey, there are a lot. Okay, we have the land survey. Actually, the one thing that you need to focus is actually here that relates to real estate is actually the cadastral surveys. okay, something, I mean, the information on your site plan that you can get from your document of title, right, has been conducted through cadastral survey. Okay, because cadastral survey determines the property boundary, the lines of boundaries, okay, property corners, right of way, and all the other data or process related to what we call land subdivisions. And then nowadays, the land surveyor's office or JUPM, for example, right, conducted what we call cadastral surveys for all new sort of development. Because new development, right, from a big parcel of land, you need to subdivide the individual plot. You need to subdivide the land into individual plots, and then this individual plots is being what? Transacted, right? Or passed on to the buyers. And then all other elements of surveying related to the what we call specifics, like construction, topographic surveys, have some specific tasks, okay, for it. But for real estate, we simply focus on the cadastral surveys. And then here I say, you know, under the surface, okay, hydrographic, okay, in water, you know, lakes, river, sea, for example. And then we have also route surveys. Okay, route surveys for preparing the roads, okay, or lines of street lines, for example, or road lines, highways, for example, right? And then they call it route surveys. Okay, and then we have also mine surveys when you do mining, for example, and then area surveys, all right? Area survey from the air. So it involves not only on the surface, but also under the surface as well as over the surface. Okay, that's what we do. And then use of surveying, of course, to prepare maps at the end of the day. So basically for us, we have what we call this cadastral map, right? As well as sometimes we also need to look at the contour map, okay, if that area is actually hilly, okay, or have contours or slopes, right? So it's good to know, besides the cadastral map to show the boundary, but we could also identify the what we call up and down, right, of the contour of the surface, all right, through contour map. And then we also have what we call the elevation survey that use that level tool just now, and then all other things related to land survey as well. And then these are some basic measurements. Only two things. One, you need to take the bearings, which is actually the angle, right? And then the distance, right? Just don't worry about all these technicalities. These are sometimes maths, something related to maths also. So let's say, for example, you have the horizontal angle, you put your tools here, let's say your total right here, and then you basically want to get point A and B, so you subtended, right? Okay, from this to A and B through here, okay? Here, this is actually the angle, right? And then you also need to get sometime vertical angle, all right? And then you subtended from A to C here, okay? Vertical. And then the other thing, actually, you need to get what we call the distance. So in general, there are two sort of data that a land surveyor needs to get. One is the bearings, okay, and then the other one is actually the distance. So bearing is very important because it shows you the directions. And then from bearing also you can, what we call, determine the angular figure, okay, here, or here, okay, or here, right? So angles can indicate what we call the true bearing, right? Because bearing follow through the actual what we call globe through north, right, readings. So we have two ways of measurement. One is direct and the other one is indirect. All right, direct measurement is actually you want to measure a distance, or you can measure an angle, or you can determine the up and down, okay, through a level, what we call equipment. And then indirect measurement is through sort of computation, right? Of course, when you get a parcel, enclosed polygon, so you can calculate the area or sometimes the volume, okay, when you do what we call true level, okay, because you can see all the density, okay, of the land features. And then there are two ways to determine the direction in surveying. One is through azimuth, and the other one is through bearing. Okay, azimuth is actually going from 0 degree to 360 degrees, and then it follows the main reference is actually the true north, right, which is actually sort of the final north, right, of the earth. Usually they refer them as the the North Pole, okay? That creates what we call this sphere, okay, of the Earth. Okay, this is actually the true north. And then the other one is also we have the magnetic what we call azimuth, okay, and we call it a bearing, okay. And then bearing follow through these 4 quadrants, okay. Quadrant 1, like 1, 2, 3, 4, right? So each quadrant indicates a 90-degree angle, all right. And then normally through, you know, north and east. Okay, so you have the this is actually what you get from your what we call bearings for the XY coordinate, right? So you have the north and also east coordinate. For example, for quadrant 1, quadrant 2, 3, and 4, right? So when you get one angle here, and then you can actually get the other angles through sort of, you know, measurement, okay, of the quadrant. So this shows how we read what we call azimuth and bearing. Okay, let's say we have 45 degrees, okay, through from the true north, or we can also have 270 degrees of the true north, right? So we don't say the position, okay, the actual position, because we measure through the true north. But for bearing, we need to look at the quadrant. Each quadrant, let's say the first quadrant involve, let's say, 45 degrees north and east. Okay, and then you also have, like here, for example, the third quadrant, we have 45 degrees south, okay, because it leads to south, and then it's actually on the west side position. Okay, so this is basically a matter of different way of reading azimuth and as well as bearing. Sometimes when we have bearings, we don't only have the degree here, 45 degree, but sometimes we have 45 degree, 10 minutes, and 5 seconds, okay, depending on the tool used, okay, for us to get what we call the bearing. Okay, these are some techniques of surveying. One is what we call the most famous one is traverse. Traverse is basically it's like a puzzle, okay. Consists a series of lines, or in GIS you can simply relate it to a polygon, right, or area, right. So basically, it's a polygon of 2D or 3D sometimes if it involves what we call some kind of leveling, right? And then the example of the use of traverse, property survey to establish boundaries, and then sometimes location and construction layout, okay, for highways, railways, and other works. This is actually the concept of traverse. It can be open traverse and it can be closed traverse. Okay, what can you sort of relate to when you talk about GIS? When we have open traverse, we can simply relate this to a what? What do you think on GIS? Anyone? Anyone? Anybody?
Don't know.
Huh?
No idea. No idea.
No idea. You look at these two pictures, open traverse and closed traverse. What these two indicate?
Area and distance.
Line and polygon.
Yes, lines and polygon can. So you see this open traverse is similar to lines feature, and then this closed traverse is actually simply a graphical of the spatial polygon object, right? So this, you know, basically traverse has the historically what we call related to GIS actually. So we have open traverse, you can do or prepare roads or streets or any way, okay, that that start from known position and then basically end with the other position. It could be known, it could be unknown, right? But it basically the points or the lines is somewhat continuous, right? But a closed traverse is start from the same point and then it ended up on the same point as well, right? So this could be, you know, simply, you know, relates to the GIS lines as well as the polygon. And this is how they simply do what we call traverse survey or of the closed type, right? So what you're measuring is actually the bearing, okay, of these lines, okay, from A to B, B to C, and so on and so forth until it encloses back to A. And then you also need to measure the distance, right, of the lines A to B, B to C, and up to H to A. All right. So basically, when you want to get bearings as well as distance from known points, okay, to the other points, so you need to have what we call this position first, A position first. So you already have the bearings or the coordinate for A position, and then you simply measure the other sort of created position, right? Depending on the shapes, okay, or boundary, right, on the land of the land. So it will simply go back to the origin point. So there are two techniques to do bearing readings, all right? One is, we call it a forbearing or forward bearing, like let's say you want to measure bearings from A to B, so we need to measure forbearing, like A to B, okay? Like A to B, you have this north reference, and what is the angle there, right? Let's say in this case, 23, right? And then you also have the other back bearing, okay? We call it BB here, right? And then you start off with B, okay, similar north here, and then you measure D through A, okay, subtended to A, right? The A to B, and then B to A. So basically, what's the difference between for a single for point A and point B? What is actually supposed to be the difference, okay, in terms of angular for a line? Anyone? So if we know bearing A is 20, the angle for A is 23. So what is supposed to be the angle for B to A? Anyone?
157.
Yes. What you do? You simply subtract the
180.
the 80, right? Okay, to the first bearing. Okay, this is actually simply math, actually, right? So basically, when we do bearing readings through this method, forward and back, so we can check each other. So point A and B should be 180 degrees of each other. So any deviation or any errors, okay, they can be sort of corrected. Okay, can be corrected, right, from the field. Basically, when you want to put position, you need to put a proper or exact sort of position. So basically, 1 or 2 degrees, okay, can be 1 or 2 degrees could be made some item for dispute, okay, especially for boundaries line, right? So you need to get what we call a proper measurement. So basically, you need to get forbearing and back bearing for all of these what we call points until it encloses back to the origin, to A position. But the table here only show you the forbearing readings. But of course, through here you can do the measurement by way of that bearing, that 4 quadrant types, okay, of bearing, right? Because each quadrant has 90 degrees angle, and if it's actually a straight line, you can get a 180 degrees angle, right? And then we have the other one is open traverse survey. Similar, you need to also indicate the forbearing as well as the back bearing readings, and then you also need to measure all the distance, right? Need to also measure the distance, okay, from point, let's say B to C, C to D, and so on, so forth. And then you can plot that onto the table of survey data here, for example. Purpose of survey traversing, there are a lot. They are also related to real estate as well. One is actually for you to prepare a map, okay, or plan, like a site plan, right? You need to do a traversing, most likely a close traverse, because you want to get a boundary, right, for the parcel of the land, right? And then you can actually depict all the features, okay, on the land as well. And for a development, okay, before construction is going to start on a plot, right? So you need to do a setting out first, right? You need to put all these points, right? So that it can prepare you with what should be built, okay, on that on the land, right? So we call it a setting out. Okay, it's actually a pre-process of actual construction, right? And also for monitoring purposes, right? And then traverse equipment, some of them, it could be a total station, or it could be a theodolite. Okay, it could be what we call the bearing compass, okay, tapes and all that. And then application of traverse. Okay, if you have known a position and then you want to create other points, so basically you can establish that points, okay, by way of traversing, right? Remember the open traverse. You have known position, but like 2 points here, this point and then that point, but you want to create or you want to read the other unknown points, right? So you can do that based on the known points. Okay, remember the principle here. It's actually known points of the origin, right? A has a reading. This point also has a XY sort of position or XY coordinate. All right. So you can base on this sort of coordinate. And then you could also from the new points you can sort of map all the other features, okay, near the area, right? Remember that first law of geography, okay, you want to know the relationship, you know, between the near, between the near, not the near distance. Yes, the near distance, okay, rather than the far distance. So basically, let's say you have one picture here, let's say a building or like a lake, for example. So you can simply also get the readings, all right? And then it also allows you to do what we call the setting out work, okay, for new constructions. Okay, just imagine a developer, all right, wants to open up a new land, okay, and then the surrounding area of that site, okay, has already established, okay, with buildings, with houses and all that. So with all other features, okay, already built up. So from that bare land, you want to build something on it. So you need to know what we call the setting out, okay, so that it simply conform to the surrounding, right? You cannot build up to the boundary, right? Because we need to create some sort of buffer, okay, from one side to the other. Okay, maybe buffer through roads or through reserve areas, for example, or through forests, right? So depending on the requirement by the local authority or the planning department. So travelers can sort of prepare the setting up work, all right, to construct, let's say, new buildings or to open up a new site, let's say a real estate development. And then we also have this, what we call the cadastral survey. All right, normally JUPM, okay, provide this service. Okay, cadastre is what we refer for in the title. All right, a parcel basis of property ownerships, and then it relates to the property boundaries. Okay, the determination of property boundaries through cadastre, and of course, cadastral surveys are controlled under the NLC. Okay, and then only determination of boundary and location, okay, of the site needs to go through cadastral survey, right? So that this land could be registered, okay, could be registered into the legal on land administration systems, okay, and then it transforms into the document of title, all right, which is actually a legal document, okay, of property or of land. And then these are some of the reasons why we need to do cadastral survey: to prepare the register, the database, okay, of all lands, right? And then to prepare the map, okay, and then to ascertain the legal ownerships, okay, of the land by producing a document of title, right? So it's simply a record or database, okay, of lands, of the owners of land, all right, and plans related to the location of the land, right? But nowadays we have what we call e-cadastre, right? Because nowadays they're venturing into more digitalization of the process. Those times they prepare a map of paper base, but now they prepare everything online, okay, through GIS medium. So they call it an e-cadastre, okay, or e-cadastre system, right? That's something government sort of JUPM sort of introduced like way back or 10 years ago, for example, to provide more ease of use or more ease of retrieving records. Remember all valuation firms when before you go inspection, right? So the valuer or maybe the officers in charge, okay, of the legal document of title document needs, we call it a title search clerk, right? Needs to go to the land office to verify the rightfully owner, okay, before you simply go to inspection, okay, of the property, right? So this is what e-cadastre would simply help, right? The persons who requires the copy of the document to provide for a very fast ease of service and all that, right? And then these are types of cadastre survey works. It's all related to to the land code and to what you have learned also, right? In the subjects, all right? Basically, we want to determine the boundaries for for state, district. Okay, but for us, we also need determination of boundaries on a very micro level, which is actually a parcel base. But here, of course, JUPEM is actually a nationwide, right? Entity. They do what we call works for state, district, Mukim city section, and so on and so forth, as well as parcel based, what we call cadastral work as well. And then this actually has some involvement. Okay, if you want to do like land alienation, acquisition of land, subdivision is the most sort of famous one. All right, and then partition as well, or amalgamation or cantongan tanah and all that. Right. Remember, in all of these mode, right, you have or you have either valuation related to all of these things, or you have some sort of calculations, right, on value or value to whom, for example, right? That's somewhat related to the valuation aspect of the cadastral work. So cadastral is very much related or directly related to real estate when you want to do what we call this land survey or parcel base survey, okay, on the map, all right? And then all of this survey work, all right, nowadays have been transformed into what we call a digital database that could be used in any GIS software. All right, I'm sure the government office as well, like Relation Department, some Relation Department on JPPH site, or Relation Department on the local authority site as well. The land office, JUPEM, okay, they all have ventures into this GIS, okay, database based on what we talk here, based on what we have on the cadastral survey, all right, or also conducted by the land survey. So everything nowadays are digital, all right. So basically, it will help you a lot when you do your work as a valuer later on. So you don't actually have to go on site. You can do, let's say if you want to determine, provided that Google Earth, okay, is the most what we call updated version of the data, right? Because Google Earth, probably the data is actually updated, right? I'm not sure on daily basis or on the spot. I don't know. It depending. Of course, you can monitor, or identify your land or your property through that, the map. So what you call it a relative position, or how to get there, okay, from your office. And then of course you bring up your maps and then through road networks, and then you can get by to your location, okay, when you want to do inspection and so on. Okay, so this is all about what we call land surveyor. And then there are a lot of resources, okay, over the YouTube, for example, or in the internet if you would like to know more about it. Okay. So I finished the lecture on land survey. Any questions on this part, guys?
Doctor, will this topic cover in our finals?
No. It won't be covered in your final. So your final exam will be something directly related to GIS. It is more of GIS material, not this one. Anything to ask on the finals? Anyone? Or anything you have doubts on GIS? Don't ask me statistics, because I said you can refer to Dr. Olan, all right? But I'm sure he has prepared you 2 questions on section A, 2 questions, but you need to answer 1, right? And I'm sure the question required you to, how shall I say this? Of course, you need to do analysis, right? Or to do calculation, but something related to, interpretation as well, right? Because statistics is all about interpretation, right? Okay, so you can have an idea of what I'm talking about, right? Okay, and then GIS also, like I said earlier on, related directly to the tasks that were given to you. Some, maybe majority of it, okay, and also like understanding the principles, and then how you relate the principles in real estate. So basically, you need to know the principles of GIS, and then how that principles can be, related in your work as a real estate person. Right? That is generally okay. Yes, Lavinia.
Yeah, no, then the GIS part is also handwritten, right? It's all.
Oh yes.
Yeah.
It's all handwritten. Yeah, basically that's a tricky part, because I originally intended you to get involved with some kind of digital work, but it's a little bit tricky because the department not favored that way actually, because they want students to write their answers. That's what I can tell you. The department, or I think the department level or the faculty level, I'm not sure, but at least on the department level, we require students to answer in writing, basically. So I cannot allow that, basically. Although I am really supporting the idea of doing your work over the computer. I like it because GIS is much more easier, right, to do work on computer, basically. But for exam, you can do that. You can't do that. You need to write your answers. Like the one you did right on your tutorial when you do your ER diagram and all that, right? So if you were asked the same question, you need to somewhat draw by hand. You don't have to draw exactly, like at least it indicates the symbol or indicates what we call the shape, okay, of the things. So basically, you need to draw when you answer such question. For example, right?
Okay,
Anything? All right. Anything else? Anyone?
So for the GIS part, is there any diagram calls to refer and then calls to describe, or a very straightforward question like discuss 3 rows, something like that?
Okay, on the last bit, there are basically describe things. I mean directly from the notes, okay. But the bulk of the questions needs you to sort of brings out the imagination and put it on paper, basically. Something related to your work, to your tutorials, and to your tests as well. That's I can give you. Yeah, Brian.
Meaning that there may be like there will be a diagram there and then calls to describe something like what we did in tutorial, is it?
Yes, true. So you need to, let's say, refer back to your, okay, not only notes, but also the tasks that were given to you, especially the tutorial parts, as well as the tests that were given to you. Basically, all the underlying principles, you have done it, okay, through the tasks. So you just need to revert back, okay, when you do your final exam, when you want to answer. Just bear in mind, because you have, yeah, Brian.
Because if we answer that type of question, maybe we'll use our own words to write.
Yeah, correct. Correct, yeah,
very simple one.
Yeah, simple one. Yeah. Simple description, short one. Because I believe the answers would be somewhat in, how can I say? Probably that some of the answers require you to have in diagram form, right? Okay, because it's GIS, right? GIS you need to imagine and somewhat show it through diagram, right? Just bear in mind there are 3 principles, right? Data on GIS, lines, point, and polygon. Okay, so you need to understand the concept there, right? And then the rest should be easy, basically. Just bear in mind the questions you need to answer 2 within 2 hours, and then 1 question accounts for 50 marks. So 50 marks for statistics, 50 marks for GIS. So altogether is 100. And then from each question, you have like, I think 3 at least. Let's say question number 1, you have A, B, C, and then question, let's say on the GIS part, question number 3, you also have A, B, C. So that 50 marks is somewhat, divided, not equally, right? It could be what, 10, 20, 20, or it could be 15, 15, 20, something like that. Right? So depending on the type of questions, okay. So the marks also commensurate with the weight, okay, or with the task that you need to do on the questions or on the answers, okay, of the questions. Okay, anyone?
Sir.
Yeah.
Is it we don't need to open our camera during the final exam?
For me, I personally don't require that actually. But I'm not sure about other lecturers because like our KJ, right, she's a bit strict on that sebenarnya. But we had a meeting yesterday. It won't be made compulsory for lecturers to require students to make the camera on, okay, during the exams. So it's up to you.
We need to depends on our lecturer whether to open or not.
I think the message is through any subjects. You are not sort of made compulsory to open your camera. You were not made compulsory, yes. So basically, I think it applies also to other subjects, to any other subject as well on GS, because you know what, only us, EM as well as I think the other department is QS, conducted these final examinations through online. But for the others, like BS, building surveyors, they mostly, I think what I've heard, they mostly most of the subject converted into what we call I think like final semester assessment, something like macam coursework or test. Doesn't have to go through examination like that, online examination. It's something like task based. Okay, you were given task and then you need to complete it within what, let's say 2 days or 1 week. Okay, that's what BS did for their students. Only maybe a handful, like 2 or 3 subjects, requires you to sit down and write your answers on the online examinations. But I think for EM, for real estate and for QS, these 2 sort of courses, right, conducted this online examination through this board, through our writing or to our examinations. And just bear in mind that some other faculties made it compulsory for students to really open up the camera because they need to monitor the examinations, and that was really somewhat in line with what the university wants actually on the higher level. In fact, university requires us to make sure that you do it individually and all that without any support and whatnot, right? But it's simply hard to do so. I don't know. What do you think? It's really hard, right, to juggle between camera and also the work that you need to do, right? Because some, there are a lot of things, right? The network area, for example, the bandwidth, and as well as the technicality aspect, right? Even so, like myself, right? Sometimes I, briefly open up the camera, but most of the time on the sessions, I simply, close it because it also affects my line. It's somewhat becoming slightly slow when I open up my camera because it involves a lot of data transfer, right, from the provider to your PC, and then from PC to you also, right? So I think a similar thing happens on your side as well. So I think we do it, on the easier mode, basically. Yeah? No camera, it's okay, no problem at all.
So because we also need to adjust the screen down, so it's actually very hard for us to see the screen.
Yeah, because sometimes when you didn't do that, right, the lecturer who watched you do the exams might strike you, right, because it's open and the microphone also is open, it is on, right? So you might be struck, right, or shocked when you were being, interject by the lecturers, okay? Like, Brian, please show me your face, for example, right? So that could be, strike you, not only you, but everyone else also while doing the exam. I think what the EC tries to do, right? They want to sort of mimic, similarly, what sit-in examination is through online examinations. That's what the motivation on the university basically. As normal as possible when you do your sit-in examination, in the auditorium. So similarly, they want us to sort of, conduct that over online. So it's quite, it's very daunting actually, right? Somewhat needs somewhat more preparation. Okay, maybe if we indicate that during the first week of the semester, then we can do that. Okay, because you have 14 weeks to do preparation in terms of getting the equipment, make sure the computer is camera ready, for example, a data plan and all that. But I think if only now we simply ask you to make it compulsory, then it will be troublesome for the students as well, basically. Okay, guys. So I wish you all the best on your examinations, not only for GS, also other subjects, because I believe, you still have another semester, right? The next semester, semester 2. So everyone has presented their proposal, right? Their thesis.
Yes.
Okay, that's good. What do you think about that? Comments from the lecturers? It's all good?
Yeah.
That's good, right? So I think the zero will somewhat sort of divide the proposal among the lecturers basically, and then that yet to be known. Okay, I'm sure in 1 or 2 weeks time. So basically after that you need to contact directly to the respective, we call it supervisors, right? When you want to do the thesis or the research part. But yesterday he told us some of the research, some of the proposal, right? Would not would not focus the topics or the title were not that focused. Some only some need to refocus or maybe need to redo, okay, a little bit. Needs to be made through proper way, some of it, I think. So he simply described through the topics or through the titles, okay, of the proposal when he presented the presentation that you have done before. Okay. But not to worry now. Okay, of course, you can work with your supervisor later on how to plan your research and up to completion, okay, of the thesis later on. And I suspect during semester 2, did you get any notification from, I think, the university to ask you to come back on March? Do you heard about that? Ada tak?
Yes.
Ada,
Yeah.
I'm not sure how they're going to do it, because I don't know, depending on the current situation of the COVID thing. I'm not sure. Just wait for the announcement. Otherwise, the next semester also will be done through online. So basically, you won't be seeing any lecturers for the whole year or for the whole session 2020-2021. Let's not hope so. Okay, let's hope that the schools or the faculties will be open on semester 2. I hope so. I hope not. I hope so. Yes, I hope so. Right? Because it's really burdening, doing online things, online work. And on our part also, we need to prepare a lot of things basically when we want to do online, and it's really hard to explain or describe, especially on the first year, because I teach first year as well. It's quite challenging to teach first year basically because they want to because they are in the process of getting into university mode, right? And then the first thing they came in actually with online learning, so they must be really shocked, okay, on that. but it's benefit them because the first year subject is mostly theories like economics, accounts, like only valuation is something, alien to them, right? So that's a big part, that's the very big sort of daunting task for lecturers to teach valuation for first year online, right? Because they can, I don't know, they can simply see. Anyway, I hope everything is going to be all right. Okay, all the best for your examinations. So I hope to see you on the second semester. And I believe you have what we call that for your project, right? Integrated project. We were told also you were going to Langkawi, is it? Is it true?
Yeah.
Yes.
Okay, somewhere in July or August, right?
Yeah.
Okay, let's hope that the case, this COVID thing has sort of becoming dead or whatnot, right? Let's hope so. Okay. All right, never mind. Okay, all the best to everyone. Thank you very much, guys.
So do we have tutorial
Yeah.
class?
Oh yeah, this
Thursday?
doesn't. No, we don't have tutorial class. Do you want one? Do you require a tutorial on Thursday? Anyone? Or if you have any questions, you can text me or WhatsApp. No problem at all. But I think we don't have the tutorial session this Thursday. Okay, guys.
Okay, noted.
Okay, thank you very much, everyone.
Thank you, doctor.
Okay, sir.
Okay, thank you.
Thank you, doctor.
Bye bye, everyone.